Hello. Today we're going to talk about how to write formulas for arithmetic sequences. There are two different formulas, two different types of formulas that we are going to discuss. The first one is what we call recursive formula. That's a formula that allows you to find the next term knowing what the previous term is. In an arithmetic sequence, to get the next term, you add the common difference to the term before that. And then the general way to write the formula using recursive formula is going to be like this. So the first example, write the recursive formula for the following arithmetic sequence that find the next three terms of the sequence. There are two things we need. We need to identify the first term, which clearly is 3. And then to find the common difference, we are going to take the difference of two consecutive terms, for example 19 minus 3, and that will give us 16. And to write the recursive formula, you are going to state what the first term is, and then you will also write that the nth term is going to be the term n minus 1 plus 16. Please remember that both of these things must be included in the recursive formula, because you do need to know what the first term is. That's the only way that you're going to be able to set up a sequence. And we know that to get to the next term, you're going to need to add 16. And we're going to use that over here to calculate our remaining terms. We're going to add 16 to 51, which will give us 67. Then we're going to add 16 to 67, which will give us 83. And then we're going to add 16 to 83, and that's going to give us 99. That takes care of the next three terms. The second problem, we have our sequence 7, 4, 1, negative 2. The first term is going to be 7. The common difference here is if I do 4 minus 7, which is the second term minus the first term, it's going to give us negative 3. And then our formula is going to be the first term equals 7. And then the nth term is going to be term n minus 1 minus 3. We can, of course, write that as plus negative 3, but it always looks better if we write that as minus 3 and avoid having double signs. And then to write the terms, the next three terms in the sequence, we're going to continue adding negative 3 to the terms. So negative 2 plus negative 3 gives you negative 5. Negative 5 plus negative 3 gives you negative 8. Negative 8 plus negative 3 gives you negative 11. And that takes care of that problem. One downside of the recursive formula is if we want to find a specific term in the sequence, you always need to know the one before that. So like for example, if you want to calculate the 10th term of that sequence, we need to know the 9th term. And to get the 9th term, we need to get to know the 8th term. So the only way you can recreate the terms of the arithmetic sequence if you have the recursive formula is if you are going to write term by term until you get to the desired term. But then we have another formula, which is what we call the nth term formula. It is also known sometimes as the general term formula. And that formula looks like this. A sub n equals a sub 1 plus d times n minus 1. A sub 1 in this case is the first term, as always, and d is going to be the common difference. So just like the recursive formula, we need to have two things before we can write anything. That is the first term and the common difference. So here's our sequence, negative 6, negative 1, 4, 9. The first term here obviously is going to be negative 6. The common difference here is going to be negative 1 minus negative 6, which is positive 5. And then to write the formula, you're simply going to write a sub n equals the first term, which is negative 6, plus the common difference, that's 5, times n minus 1. And that is going to take care of that. What are the benefits of using the nth term formula is that it will allow you to find any term of the sequence that you want without having to find any terms prior to that. And I'm going to demonstrate that. But first let's finish this problem. So we need to write 3 more terms. We know the common difference is 5, so we're going to continue adding 5. 9 plus 5 is 14. 14 plus 5 is 19. 19 plus 5 is 24. But here's an example. If I want to find, let's say, the 21st term of this sequence, all I need to do is use 21 for n. So I'm going to write negative 6 plus 5 times 21 minus 1. And then we do the math. Of course, we need to make sure we follow the order of operations, which means parentheses first, then multiplication, then addition. 21 minus 1 is 20. 5 times 20 is 100. Negative 6 plus 100 is 94. And that's how simple it is if you have the nth term formula. And the last problem we're going to do is this sequence, same exact question. So we take the first term, which is 3, and then we need to find the common difference here. It's a little bit more challenging because there are some fractions involved. So the common difference here will be negative 1/2 minus 3, and if you calculate this, that's going to end up giving you negative 7/2. So then for the nth term formula, we're going to write a sub n equals the first term, that's 3, plus negative 7/2 times n minus 1. This is correct, this is okay, but I would like to rewrite that a little bit different because we have plus negative here. We can also rewrite that as 3 minus 7/2 times n minus 1. It's always easier to avoid having double signs, and that's what we just did here. Okay. And then to find the remaining terms of the sequence, we're going to have to continue adding negative 7/2 because it is negative 7/2. So negative 15/2 plus negative 7/2 is going to give you negative 22/2. Negative 22/2 plus negative 7/2 is negative 29/2. And negative 29/2 plus negative 7/2 will give you negative 36/2. We do need to make sure that all these numbers are simplified. And if you look over here, that's actually negative 11. Can't do anything about negative 29/2, that's going to stay like that. And negative 36/2 will simplify to negative 18. And that takes care of the next 3 terms of the sequence. Okay, I hope this helps.